Good evening, students. This is Dr. Garima Agarwal from Manipal University, Jaipur. And in my previous lecture, we have discussed these points, that is determinant, cofactor, minor, adjoint, inverse, rank of matrix, eigenvalue, eigenvector, and Kelly-Hamilton theorem. Now today we'll discuss consistency of this system. First of all, what is the meaning of system here? What we are trying to say by consistency of system? Two terms are new here, I guess. One is consistency and second is system, right? So first of all, what is system? Let's say we have a linear equations like that. Here a11, a12, a1n, a21, a22, a2n, am1, am2, b1, b2 up to bm, all are constants, right? So if we write all the left hand side constant in a matrix, all these right hand side, I mean left hand side constants, we write it in this same sequence but in a matrix form, right? It is known as a matrix A or coefficient matrix. Why coefficient matrix? Because these terms are coefficient of variable x, right? Then all the variables x1, x2 up to xn, we write it in a column matrix, and the right hand side constant in a different matrix denoted by B in a column matrix, right? Then this then in that case we can write this system in a matrix form Ax is equals to B. Small b or capital B, you can denote any notation over there. Capital B is also acceptable, right? So Ax is equals to B. If I multiply A and X, that is first row into first column, then second row into column, then third row into column, we'll again get this matrix, right? So this is known as system of equations. Am I clear? This is known as system of equations. If we write all the linear matrix in all the linear equations in a matrix form, then it is known as system of equations, right? If we write these two matrices A and B together like that, then it is known as augment matrix, right? If this system of equation possesses a solution, then it is known as consistent system, right? If any solution exists for the given system of equations, then it is known as consistent system. Otherwise, it is known as inconsistent system. Clear? Now, how we can find the solutions? How we can say that it is consistent? There are few rules to find the solution of the equation. So the first is the system Ax is equals to B is consistent if and only if the matrix A and augment matrix AB are of same rank, right? If the number of equation M is greater than the number of unknowns and rank of A is not equals to rank of augment matrix, then system of equation is inconsistent. That means in that case we don't have any solution. If rank of A is equals to rank of augment matrix is equals to n, n is what? The number of unknowns. Here n is number of unknowns, then the equation are consistent and have unique solution, right? Then unique solution means specifically will get the value of x, y, z, like any particular value 1, 2, 3, something like that, right? if rank of matrix is equals to rank of augment matrix is less than n, then the number of unknown n is the number of unknowns, then the equation are consistent and have infinite number of solutions. What is infinite number of solution? Let's say if I get a result like x is equals to y. So in that case, I have infinite number of solutions because the value of x and y could be 1 or it could be 2 or something like that, right? In the what is homogeneous system of equation? In homogeneous system of equation, all the right hand side value is 0. If all the values of b1 b2 is 0, then it is known as homogeneous equations. For homogeneous equation, the rank of matrix A is always equals to rank of augment matrix because b is 0. So whatever the rank of A, it will be the rank of augment matrix. So homogeneous system of equation are always having solution and it is consistent, right? If the number of equations is same as number of unknown, then the non-zero solution exists only if the coefficient matrix is non-singular, right? Now let's discuss few example based on this rules of consistency. Here we have two equations, two set of linear equations. So first of all, we write the coefficient matrix A. Coefficient matrix is coefficient. Just write the coefficients in the same order and in the same sequence. Right, so this is the coefficient matrix. X is the variable matrix. Just write all the variables which exist in the given equation in the column matrix form. Then write B, that is the right hand side constants. Then augment matrix, that is A colon B, right? Or matrix A, this is matrix A and this is matrix B, right? Now we need to calculate the rank of A and rank of augment matrix. So rank of augment matrix and the rank of matrix A. Rank of augment matrix is 1 and rank of matrix A is also 1. You can find the rank in your through your method. Here they are using the different method which I don't want to explain over there, otherwise you guys will get confused. So you can solve it by your method. It's very simple to find the rank: -4, 5, -3, -8, 10 and -6. I applied the transformation on R2, that is R2 minus 2 R1. So it will be -4, 5, -3, 4 minus plus 8, -8 plus 8, that is 0, 10 minus 10, 0, -6 plus 6, 0. That means rank of matrix A is, by these four terms we can find the rank of matrix A, that is number of non-zero rows, which is 1. And rank of augment matrix is also 1 by using all the elements. We can say that rank of augment matrix is 1, right? But number of non-zeros are 2. So the system has infinitely many solutions. Clear? In the next question, we have 3 linear equations. So we write the coefficient matrix, variable matrix B, the right hand side constant and augment matrix together A and B, right? Then we find the rank of matrix here. So by these 9 numbers you can find the rank of matrix, that is 3, because number of non-zero rows is 3, and by all the elements we can say that the rank of augment matrix is 3. So rank of A, rank of augment matrix and number of unknowns all are 3, that means system has unique solution, right? Now what will be the unique solution? Now you can write the unique solution through this matrix. Let me write this matrix here again. This is the matrix, right? This is the coefficient matrix. If I write it in this form, what I'll get, this is B, right? And this is coefficient matrix, augment matrix. This one is augment matrix now. So the right hand side term is this one. So x1 plus 2x2 minus x3 is equals to 1, this one. Then 0 minus 2x2 plus 5x3 is equals to minus 5, and minus 3x3 plus 9x3 is equals to minus 3. Now by this third equation we can find the value of x3. Then substituting the value of x3 in the second last equation we can find the value of x2, and by substituting the value of x2 and x3 in first equation we can find the value of x1, right? Here also we have 3 linear equations. So first of all we'll write the coefficient matrix, augment matrix. Then we apply the transformations in this matrix. Okay, in this question we have a few constants as unknown, that is A and B. These are the unknown constants. So after using row transformation we get a term like that, right? Now we need to decide what will be the value of A and what will be the value of B, so that the system will be consistent or not consistent, right? So the first case, if A is not equals to 5, in this case for any value of B we have rank of augment matrix, and rank of matrix A is 3, which is equals to number of unknowns, because this term is A minus 5B, right? This term will be 0 if A is 5 and B is equals to 1. Am I clear? So this term cannot be 0 if A is equals to 5, right? So in that case the rank of A and rank of augment matrix and rank of unknown all will be 3. So the system is consistent and unique solution if A is not equals to 5 and whatever the value of B, right? Now if A is equals to 5 and B is not equals to 9, in this case the rank of augment matrix is 3 and rank of matrix A is 2. So the system has no solution and known as inconsistent. If A equals to 5 and B equals to 9, in case rank of matrix augment matrix is equals to rank of A is equals to 2, which is less than number of unknowns. So the system is consistent but having infinite number of solutions, right? If you guys have any problem in consistency of the system, please raise your hand. No? Okay. So let's discuss Cramer's rule. We use this rule to solve the equations by using determinant form, right? Let's say we have this linear system of equation. So first of all, we write all the coefficients in the determinant form. This determinant should not be equals to 0. If this determinant is 0, then we don't have any unique solution, right? Then what we'll do, we'll represent this determinant of coefficients by this triangular sign known as delta. Then what process we are following in Cramer's rule? First of all, we need to find the value of x, right? So we'll remove all the coefficients of x and write b1, b2, b3, which is the right hand side constant. Then coefficient of y, coefficient of z upon delta. Similarly, to find y, we remove all the coefficients of y and write here the right hand side constant b1, b2, b3. This one is coefficient of x, coefficient of y, coefficient of z. Then similarly, in z, we remove all the coefficients of z and write the right hand side constant over there and divide it by delta. Right. So we denote this determinant by del 1, del 2 and del 3. By simplifying, we can find the value of x, y and z. Right. Here we have one example. This is the linear equation. Del is the coefficient matrix, that is 2, 1, 3, 3, 1, 2, 1, 2, 1. Sorry, 4, 2, 1. Right. Then del 1. Instead of using the coefficient of x, we use the values of b, that is 29 and 10. Here b and here b, right? Then coefficient of y and then coefficient of z. These are the coefficient of y, these are the coefficient of z. Similarly, this one is coefficient of x, this one is coefficient of z. Coefficient of x and coefficient of y, right? Then we solve this all these four determinants by our usual process. So we get del, delta 1, delta 2 and delta 3. Now the value of x is delta 1 by del, the value of y is delta 2 by del and similarly delta 3 by del. So these are the values of x, y and z, right? So in this unit today we discuss the consistency of the system and Cramer's rule. If you guys have any problem, please raise your hand. Okay, fine. Fine. So let's start the next unit, that is partial derivatives. So in this unit we discuss the partial derivatives, concept of chain rule, functions, exact functions, derivative of exact functions, extreme values and Jacobians, and double triple integral. These topics we cover in this unit. This is unit 7, right? So first of all, what is partial derivative and what is the difference between partial and total derivative? First thing, derivative we denote it by d by dx. This is total derivative. Then del by del x, this sign del by del x is known as partial derivative. This is the notation for total and partial derivative. Right. Now let's say the function is of single variable x. Then the derivative of x, or then the derivative of the function means rate of change in fx as x changes, right? But now if we have a function more than one variable, right, several variables or more than one variable, it depends if we only want one of the variable to change, right? So in case the partial derivative, we change only one variable and other variables are kept as constant. So this is the definition of differentiation, partial differentiation, right? This definition is more or less same as the derivative formula, but there we use the single variable and here we are using two variables x and y, right? Minimum two variables are required to use partial derivative, right? This del f by del x can also be denoted as fx. This is partial differentiation of f with respect to x. That can be denoted by fy. This is partial derivative of f with respect to y. These are the first order partial derivative of the functions. Right. These are the second order partial derivative of the function. Del 2 f by del x2, that is del by del x of del f by del x, and we can write it as f x x as well. Similarly, second order partial derivative can be written as f y y. This can be written as f x y or f y x. Both the terms are same. The sequence uh, is not important in this partial differentiation. Both values of both the terms will be same, right? And this is a mixed partial derivative. So let's discuss one example based on partial differentiation. We need to find del f by del x and del f by del y at the point 1, 2, where the function is 2x square minus xy plus 2y square. This is the function and we need to find the partial derivative at the point 1, 2. So what will be the value of del f by del x? It's as good as the normal differentiation. The only changes is if we are doing differentiation with respect to x, y will be treated as constant. If we are doing differentiation with y with respect to y, x will be treated as constant, right? So if we are trying to do different partial differentiation with respect to x, what will be the differentiation of 2x square? That is 4x. What will be the differentiation of xy? That is minus y. Differentiation of x is 1, y is constant. And differentiation of 2y square is 0. Because y is constant, 2 is constant. Now we need to find the differentiation at point 1, 2. That means x should be replaced by 1 and y should be replaced by 2. So just substitute the value of x and y, that is 1 and 2. We'll get 2. Now if we partially differentiate with respect to y, that means x will be treated as constant. So differentiation of 2x square is 0 because x is constant. Differentiation of xy with respect to y. Differentiation of y is 1. Differentiation of x will be unchanged because x is constant here. And then differentiation of 2y square is 4y. Now if we apply the values of x and y, that is 1 and 2, we'll get partial derivative with respect to y at the point 1 and 2. Sorry. Now in this example, we need to find the differentiation of this function, partial differentiation of this function with respect to x and y. Fx, this fx means del f by del x, means y will be treated as constant. So differentiation of x cube is 3x square, y is constant. Then differentiation of e raised to xy square, differentiation of exponential is exponential itself, and differentiation of xy square will be y square only. Similarly, we can find differentiation of the function, partial differentiation of the function with respect to y, and x will be treated as constant, right? Now the question is, find the second order derivative of the function. So second order derivative fxx, fyy, fxy, and fyx all are known as second order derivatives, right? So let's start with fxx. Del by del x of this term, right? Because we need to find fxx, that is 2 times partial order derivative. So partial derivative of cos 2x is minus 2 sin 2x. Partial derivative of this term is 2x e raised to 5x, and partial derivative of order derivative of this term is 0. Then again partial derivative of this term is differentiation of sin 2x is cos 2x times 2, and differentiation of this term here e raised to 5y will be constant, and differentiation of x is 1, right? Similarly, we can find the second order partial derivative. Then del 2f by del y del x. Here the sequence is not important. First we can differentiate with respect to x, then y, or first we can differentiate with respect to y and then x. Both the values will be same, right? So here if we when we are applying partial differentiation with respect to x, that means y is constant. So differentiation of cos 2x is 0. Difference in this term e raised to 5y is constant, and differentiation of x square is 2x. I'm sorry, differentiation of cos 2x will not be 0 because we are differentiating with respect to x only. So differentiation of cos 2x is minus 2 sin 2x. Differentiation of 3y square is 0 because we are differentiating with respect to x and y is constant. Now we'll differentiate this term with respect to y. Right, so sin 2x will be constant and it will be 0 after differentiation. 2x is constant, differentiation of exponential is exponential, differentiation of 5y is 5. So it will be minus 10x e raised to 5y. Similarly, we can find this differentiation, right? Here we need to find fourth order derivative, that is f x y z z. X, y, z, z. Right, so first of all we'll differentiate this term with respect to z. So differentiation of z cube will be 3z square. Then again we'll differentiate with respect to z. So differentiation of 3z square will be 6z. Then we'll differentiate with respect to y. So differentiation of y square is 2y. And then we'll differentiate with respect to x. So differentiation of ln will be 1 by x. Right? This is third order derivative. Here we need to find del 3y by del y del x2. Right? So differentiate with respect to x 2 times and then differentiate with respect to y. Here we are verifying that the values of both the terms are same. You can easily verify it at your own. And we have chain rule. Okay, fine. If you guys have any problem in partial differentiation? Please raise your hand. No? Fine. So the next is chain rule. Let's say Z is function of, let's say Z is function of X and Y, X is function of T, and Y is function of T, right? Z is function of X and Y, X is function of T, and Y is function of T. Then how we can find the derivative of Z? dz, ultimate, if we substitute the value of X and Y here, Z will be function of T, right? So we need to find dz by dt. Am I clear? I need to find dz by dt. But Z is function of X and Y. That means I can differentiate Z partially with respect to X or with respect to Y. Now X is function of T, so I can differentiate X with respect to T. Because X is function of single variable T here, right? That's why I'm using dx by dt. Z is a function of two variables, more than one variable. That's why I'm using partial derivative. Then dy, similarly dy by dt. So this is the formula to find the differentiation if the function is of two variables and both these variables are function of another variable t, right? For example, the function f is x e raised to xy, x is t square, y is 1 by t, and we need to find df by dt. Okay? So this is the formula. You need not to learn this formula. You can you can write this formula at your own. Like if you want to find df by dt, right? Let's start with this f. F is function of x and y. That means I can partially differentiate f with respect to x and y. Then here it is x, right? Now go to x. X is function of t only. That means we can differentiate it with respect to t. Plus, similarly y is function of t, so I can differentiate it with respect to t, right? Or you can write this formula as well. Because for single variable, the partial derivative and total derivative is same. If x is equals to t square, dx by dt will be 2t and del x by del t will be 2t only, right? So for single variable, the total and partial derivative is same. So how we can find df by dt? Just write the value of f and x. So the value of f is x e raised to xy, right? Then the value of x is t square, the value of y is t inverse. And then partial differentiate this term with respect to x. Differentiation of t square with respect to t. Partial differentiation of this term with respect to y. And differentiation of t inverse with respect to t. Right? Now at the last we need to substitute the value of x and y. Now this is the alternate method. Initially you can substitute the value of x and y in the function and then differentiate it with respect to t. Here z is function of x and y, x is function of t, y is function of t. So we use this chain rule. We substitute the value of f, x and y here and then differentiate it and then substitute the value of t, that is pi by 2. Right? Now we have few special cases of chain rule. But before that, if you guys are having any problem in chain rule, please raise your hand. No? Okay, fine. So in that case, let's discuss few special cases of chain rule. Is function of x and y is function of x, then the chain rule will be what? What will be the chain rule? We need to find dz by dx, right? Because y is function of x. If we substitute the value of y here, the whole function will convert into x. That's why we need to find the differentiation of z with respect to x. So let's try to write the formula. You need not to learn it, right? Z is function of two variables. That means z can be partially differentiated with respect to x and y. Then x is function of x only and y is function of x. No need to write this term. I just write it to here just to make it simple. That's it. It will be one only, right? So this is the formula. By substituting all the values, we can find the derivative of the function. Here z is x ln xy plus y cube, y is cos x square plus 1, and we need to find the values by using this chain rule, right? Just substitute the value of z and y. Substitute all the values in the numerator only. Need not to write the value in denominator, right? Because you need to find the differentiation with respect to x. Then just find just to write the derivative of all the terms. That's it. Here f is function of x and y is function of x. So we use this formula. We substitute all the values and find the derivative. Now chain rule for more than one variable. Let's say z is a function of x and y, then x is function of uv and y is also function of u and v, right? And then we need to find the derivative, right? So the left hand side will be now partial differentiation. In the previous rules, the left hand side is total differentiation, but now here it is partial, del z by del u, del z by del v, right? del z by del u. Now z is function of x, that means I can differentiate z with respect to x and y. Z is function of x and y, na? So we can partially differentiate x with respect to x and y. Then x is function of u and v, but I am interested in u only. That means del x by del u plus similarly del y by del u. If I need to find del z by del v, again z is function of x and y. Then x is function of u and v, but I am interested in v. So these are two formulas, right? Here you can see f is function of x and y, x is function of r and theta, y is function of r theta, and we need to find del z by del r and del f by del r and del f by del theta. So the formula to find del f by del r is this. Just write the value of f, x and y in the numerator, right, and differentiate it accordingly. Just remember, if you are partially differentiating with respect to x, that means the other variables, if you are partially differentiating with respect to x, that means y is treated as constant, and if you are partially differentiating with respect to y, that means x will be treated as constant. These are few examples based on chain rule. You can yeah, any query related to this chain rule for more than one variable, please raise your hand quickly.
Hello, ma'am. Kindly
Yes.
repeat the third rule again.
Third rule. This one?
Yes, ma'am.
Okay, fine. So let me delete this things that I have written over there. I will rewrite it. Please mute yourself, Vision. Thank you. So here what we have, z is function of x and y, right? Then x is function of two variables, u and v. Similarly, y is function of two variable u and v, right? Z is function of more than one variable. That means partial differentiation of z can be done, right? So we can find partial differentiation of z with respect to u and v. Two options are there, right? So let's start with del z by del u. But here we can see z is function of x and y. That means just write del z by del x and del z by del y. Now x is function of two variables u and v, but we are differentiating with respect to u. Okay, done. Similarly, here also z is function of two variables x and y. Then x is function of two variable u and v, but we are doing differentiation here with respect to v. Clear?
Okay, ma'am.
Any other student? No? Now this is the generalization of chain rule. X could be a function of n variables, say x1, x2, x3 up to xn. T is function of m variables. Then del z by del t. How we can find del z by del t? Here z is function of n variables. That should be f, I guess. That should be z. Z is function of n variables x1, x2 up to xn. That means z can be differentiated with respect to x1, x2 up to. Then t is function of m variables, so we can differentiate x1 with respect to x2. So this is the generalization, right? Like here w is function of x, y and z. Then x is function of t, y is function of t, z is function of t. So what will be the value of dw by dt? W is function of three variables. So we will write del w by del x, del w by del y, del w by del z. Then x is function of t, y is function of t, and z is function of t. Right? Now the implicit functions. What is implicit function? In which the dependent variable is not expressed in term of some independent variable and is denoted by a function of xy is equals to 0. Then it is known as implicit functions. These are the examples. What is the process to find the derivative of implicit function? First, differentiate each term with respect to x. If there is any term containing power of y, we'll first differentiate it with respect to y and then multiply it by dy by dx. Now for fxy is equals to 0, differentiate it with respect to x and get this term. Higher partial derivative of implicit function can be defined by this term, provided fy is not equals to 0. Now this is the example. Find dy by dx at 2, 4 for this function x square plus 3xy plus y square is equals to 11. So differentiation of x square is 2x, differentiation of 3xy. So differentiation by using u into v formula. While differentiating x, we get 3y. While differentiating y, we get 3x, and y differentiation of y is dy by dx. Differentiation of y square is 2y times dy by dx is equals to differentiation of 11 is 0. Then we collect the terms of dy by dx. We can write it as 2x plus 3y plus dy by dx, 3x plus 2y is equals to 0. Then dy by dx will be minus 2x plus 3y upon 3x plus 2y. Now at the point 2, 4, that means minus 2 plus 3 right? Here we have one more example. We need to find the derivative of this function. So differentiation of y raised to 4 is 4y cube dy by dx. Differentiation of x raised to 5 is 5x raised to 4. differentiation of x square is 2x, differentiation of 1 by x is 1 minus 1 by x square. Then we find the value of dy by dx by shifting all the terms in the right hand side. Now the question is, find the slope of the tangent at the point 2 minus 1. So the slope of tangent is dy by dx, which is nothing but the differentiation. So we need to differentiate it simply, and and at the point 2 minus 1, that means at the last we need to substitute the value of x as 2 and the value of y is minus 1, right? So differentiation of y is dy by dx, differentiation of y cube is 3y square dy by dx. We just collect all the terms of dy by dx and substitute the value of x and y. Right? Then here we need to find the second derivative of implicit functions. So differentiation of differentiation, we just find the derivative. We just find differentiation and then two time differentiation, second order. We need to find the second order derivative now. So we'll do two time differentiation and write it in that manner. The next is exact differentiation or total differentiation. If you guys are having any problem, please raise your hand. No? Okay, fine. In general, if you are facing any problem in my subject, in my lecture, please let me know. I would like to finish this topic over there only, because the next one is bit lengthy, so we'll take it in the next lecture. Meanwhile, if you guys are having any problem in my subject or in my lecture, please let me know. Yes.
Can you move the backside, please? This one. Can you please explain this one? No, below. This one.
This one, this question?
Yeah.
Okay. So the question is, let me write here again, xy plus y square is equals to 4, right? So the first order differentiation will be differentiation of x is 1, y will be unchanged. Then x differentiation of y is dy by dx plus 2y dy by dx is equals to 0. This is first order differentiation. And question is asking for second order. So let's differentiate it again. So differentiation of y is dy by dx plus differentiation of x is 1, dy by dx will remain unchanged, plus x and differentiation of dy by dx is d2y by dx2 plus 2 differentiation of y is dy by dx, and this dy by dx is unchanged, so I'll write it as whole square, plus 2y, and differentiation of this term will be d2y by dx2, which is equals to 0. So by adding these two terms, we get this term x d2y by dx2, 2 dy by dx whole square, 2y d2y by dx2 is equals to 0. Now we need to find the second order derivative, right? So I just collect the coefficients of d2y by dx2 and shift the remaining term in the right hand side. Am I clear?
Yeah. Okay. Thank you.
Any other question? A part of today's lecture, if you are facing any problem in assignments or in any other topic or any other problem related to my subject, my lecture, please let me know. No? Good. So let's conclude this session. Monica, can we conclude here?
Yeah, thank you, ma'am, for such an informative session. If still learners have any doubt, then they can post it over the discussion board.
Yeah.
Have
Okay.
a nice day, everyone. Thank you.
Thank you. Thank you.